All right, well, we'll pick it up on number 14. We're going to finish 12.1 today, start 12.2, and then finish 12.2 tomorrow is the plan. All right, so express the sum using summation. So this is those science ones I was talking about where you work backwards, right? Work backwards. Can you do that? Can you take these formulas right here, these results, and work backwards to the formula? Am I making sense on that? You know what I'm talking about? So in other words, which one of these formulas is going to work? So somehow you got to have a formula where you plug in n equals 1, or k, I guess it's k equals 1, and you get 4/5, and you plug in k equals 2, and you get 6/7, and you plug in k equals 3, and you get 6/7. You know what I mean? Come up with some kind of formula for k, where if you plug in k as 1, you get 4/5. You plug in k as 2, you get 5/6, etc. So what's that formula? So the top is 4, so that's adding 3 to k. If k is 1, that's adding 3 to k. And the bottom is 1 more than that, it's k plus 4. Does everybody see how I'm coming up with that? See, if I put in 1 for k, that'll be 4/5, won't it? You see that? Does that make sense? If you put in 1, you get 4/5. If you take that same formula and you put in 2, you get 5/6, etc. See how it's working? See how that's the formula that's producing those terms? Is that okay? So you just, how did I come up with that? I just looked and I said, look, how do I get a 4 on the top when I plug in a 1? How do you, if I said, hey, I'm going to take 1 and I want to make it 4, what do you got to do to the 1? You got to add 3 to it. So the top must be k plus 3. And I'm going to put in 1 and I want to get 5 on the bottom. So what do you got to do to it? You got to add 4 to it. See how I'm looking at that? Does that make sense? And where did I come up with the k stuff? Well, the first one is always 1, then 2, then 3. Then you got to plug in 1 and get 4/5. Plug in 2 and get 5/6. See how that works? Hey, any other questions? Why does it only go to 12? It's answer C. Why does it only go to 12? Is that right? What happens if you plug in 12?
It would be D, not C, right? Because if you plug in 12 in the K, it would be...
Oh yeah, it's not C. It's D. Yeah, thank you. Because if you plug in 13, that'd be right. That'd be 3 plus 13. That would be 16 over 17, which is the real last term. Yeah, it's D, isn't it? 13 is the last thing you plug in. Good job. See how that works? It's got to go all the way to 13. Remember when you do the summation notation, the number on the bottom is where you start. The number on the top is the end. It's the last thing you plug in. Right? Last thing you plug in is 13. You're going to get 3 plus 13 over 4 plus 13, 16, 17. Make sense? Are we good? Can we move on? Can I skip? This one, they kind of give it to you. They basically hand it to you. They're saying, okay, what's the formula that's going to make a 5, then a 5 squared over 2, then a 5 cubed over 3? I wonder. It's that. When they put the last one with an N, that's it. That's it. Right? It's just, but you do it with a K, because they're using K instead of N. So you, okay, I'll do K instead of N. And this is N. Is that confusing? That makes sense? Because remember, the K is this is the end and the start. Start at K equals 1, plug in 1, plug in 2, plug in 3. Although the last one you plug in is N. When you plug in N, it'll be 5 to the N over N. Right? That makes sense? So that's easy. When they give you the last one like that, they're handing it to you. Is that all right? I'll keep moving. All right, what's that one? Let's try that one. Number 16. I'll give you a second. They just want you to find the sum. They just want you to find the answer to the whole thing. See if you're comfortable, getting more comfortable with that sigma notation, that big Greek S. Let me help out. So, remember what that big Greek S says. It is. It is like a trick question. So this is a big Greek S, right, which stands for sum. And it says take the formula, which is really just a 4. It's really not much of a formula because it doesn't even have a K. It doesn't even have a plug-in spot, right? But still, we're still going to make a K equals 1 term, a K equals 2 term, a K equals 3 term, a K equals 4 term, etc., all the way to the last one, which is what, 14. You're going to still have 14 terms. Does that make sense? You're gonna take this formula, which is really not much of a formula, and plug in 1, plug in 2, plug in 3, all the way to 14. But look, when I plug in, nothing happens because there's nowhere to plug in, so it's just 4. And the next one's just 4, and the next one's they're all just 4. Because there's nowhere to plug the K in. Does that make sense? It's just a bunch of 4s. But they're added up because it's a big Greek S, which means sum, right? The Greek S stands for sum. Add them up, sum them. So what are we adding up in the end? 14 4s. It's just 4 times 14, which is what, 40, 56? The answer is 56. Yeah, it's like a trick one because there's no place to plug in the K. So they're just all 4s. There's just 14 4s. Does that make sense on that? The big Greek S means go from K equals 1 to K equals 14, plugging in K, but there's nowhere to plug in. And then just add them up. Okay, let's try. All right, so try that one. Go from 1 to 5. So see how it's going from 1 to 5? So take the formula 5K plus 4. You're going to plug in K is 1 to the 5K plus 4 formula. You're going to plug in K is 2 to the 5K plus 4 formula. You're going to plug in K is 3 to the 5K plus 4. K is 4 to the 5K plus 4. And K is 5 to the 5K plus 4. That makes sense on that? Because they're saying, start at 1, end at 5. Start at 1, end at 5, plug into 5K plus 4. And then just add them up when you're done, right? Because it's a Greek S, stands for sum. Sum them up. See if you can get that. Doing okay. So when we plug in a 1, plug in a 2, plug in a 3. It's a 3 there. Plug in a 4, plug in a 5. What do we get? 5, 9. Plug in a 2, 14. 15, 19. Just going up by 5 every time, huh? 24, 29. What's that? Yeah, nice little pattern. Just add them up now, right? Somebody got a total there? 172? That seems big. 95? Just 95, right? Good. Questions on that one? Yeah, all good? All right. Okay, so we have a sequence. Basically, they're just giving me a formula right there, n plus 9. And they're saying the sequence is arithmetic with a common difference of, okay, so basically that's a formula. n plus 9. S sub n is n plus 9. So let's find s sub 1, s sub 2, s sub 3, s sub 4. Let's plug into that formula. Remember how these always work, right? You plug in 1, plug in 2, plug in 3, plug in 4. Let's just see what we get. So if we take the formula n plus 9 and we put in a 1, we're going to get 1 plus 9, or 10. Good so far? Now let's go back. Let's plug in 2. 2 plus 9, which is 11. Let's plug in 3. 3 plus 9, 12. Let's plug in 4. 4 plus 9, 13. So this is the first term, second term, third term, fourth term. So notice it's 10, 11, 12, 13, dot, dot, dot. That's the sequence that this formula produces. Makes sense what I'm doing there? I just took that formula, just plugged in 1, plugged in 2, plugged in 3, plugged in 4, found the terms. Now, what are they asking me for? It's arithmetic, common difference. What is the common difference? Like, from 10 to 11, what's the jump? From 11 to 12, what's the difference? From 12 to 13, what's the jump? It's going up by 1 every time. That's called the common difference. I just call it the jump amount. The common difference. The difference from term to term is positive 1, isn't it? It's in common. It's always a jump of 1. Like that. And I don't know what part. There's a part 2 there. Quick. Questions on that one? Good. Okay. All right, let's try this one. So they're giving me a different formula now, 7n minus 8. Go ahead and just crank out the first 4 terms. Just find the first term, second term, third term, fourth term. Look at 1, 2, 3, and 4. Let's see what you get. Give you a second. And then they want the common difference. You know, what's the jump amount from term to term there? Okay, so you plug in 1, you get 7 times 1 minus 8, which is negative 1. Good so far? Then plug in 2. 7 times 2 is what, 14 minus 8? 6? 6. And then plug in 3. 21 minus 8. Is it 13? Plug in 4. Is it 20? So the terms are negative 1, 6, 13, 20, and on we go. Good so far what I'm doing? Now, what's the difference from term to term? What's the jump, in other words? It's going up 7 every time, isn't it? So that's the common difference, or the jump. Plus 7. And then the other parts, they're just going to say, what are the first 4 terms? There they are. Is that good so far? Can we make an observation to save some time? How can you just look at the formula and figure out what the common difference is going to be?
Yeah.
Where is it? It's the number in front of the n, right? There's a plus 7 in front of the n. The common difference is plus 7. It's like a slope, isn't it? That's like y equals mx plus b. You get it? That's exactly what it's like. It's like a slope. Did that work on the last one? What was in front of the n on this one? 1. That was it. Yeah, it's working.
That will always work? Or?
When they give you a formula like that, a linear formula, an mx plus b, then the common difference will just be the slope. Yeah. They're not going to give you a lot of these, so it's not like it's a real major helpful observation. All right, so look at that one. What's the common difference going to be? Negative 6. Notice you're expecting the terms to go down by 6 every time, because that's the slope. It's like a line headed down, in other words. Huh? Yeah, so we know the answer to the first part, common difference negative 6. But then they're going to ask you to find the first 4 terms. I'm going to move on to another problem. You could do that, right? Just plug in 1, 2, 3, and 4, and you would find them. Kind of Kind of didn't expect natural log to show up. All right. Well, I don't know. You know, I really don't. As I look at that, I would just plug in 1 and just get started. I wouldn't try anything fancy. Just plug in 1, plug in 2, plug in 3, plug in 4. If you plug in 1, you get natural log of 4 to the 1. Well, that's just natural log of 4. I mean, I guess it's some decimal thing. Who knows? I'm going to do the next one. Natural log of 4 squared.
Would the n go in front of the ln?
Yeah, nice. Let's do that. Yeah, you're right. Right. Or you could just do the powers each time. Like the 2 comes down front. Or you could have just done the n from the beginning. Good observation. Either way. Yeah, remember that quality of logs that powers come to the front? I think that's exactly what we should do. Good observation. Good. Yeah. And then the 3, you know, so they're all just going to come to the front, huh? Those powers. Exactly. Good. You guys know some log rules now. Yeah. Right. So those powers just come to the front, like that. Right. It's one of the probably the best quality of a log. So we got that. So what then? Well, that means our first term is natural log of 4. The second one is 2 natural log of 4. Then 3 natural log of 4. Then 4 natural log of 4. Dot dot dot. Is that good? All right. Now, what is the common difference? Like from term to term, what's it going up by every time? Is it natural log of 4? Is it going up by another natural log of 4? Robert thinks so, and he's usually right. He's right here again. It is, isn't it? Right? Because this is 1 natural log of 4. This is 2 natural logs of 4. This is 3 natural logs of 4. This is 4. Every time there's 1 more natural log of 4, isn't there? It's added another natural log of 4, hasn't it? Does that make sense? It's increasing by a natural log of 4. Not only that, let's put with it Carlo's observation, right? About putting the n in the front first. If we put the n in the front right in the beginning of the formula, it would have been that. Same formula, right? You can put the powers in the front. And remember what our rule was? Whatever's next to n is the slope, is the common difference. Natural log of 4. Yeah, of course. I like that when math all agrees. Well, it always agrees. I just can't always see how it agrees. When I see it, then I'm like, yeah, I'm getting this. I'm getting this, right? We see it from the slope, from the other thing. It's all in agreement. It's telling the truth. We're onto it there. Is that good? Does that make sense? That was tricky. We just had to use that log property is what it was all about. Okay. Oh, whoops. Not this one. Let's try again. I still have the same one. Sorry, I'm having technical issues. Again. All right, there we go. So A1 is minus 7, D is 4. What that means then, A1 is the first term. So they're giving us the first term in the list, and the D stands for the difference, or the jump is what I always call it, from term to term. So, what do they want in this? They want an A sub n formula.
They want the general term.
Oh, they do. I didn't realize. I was going to start cranking some out. They want the general. Yeah, let me give you the formula for that, guys. It's A sub n is A1 plus D times n.
Times n minus 1 quantity squared. Well, not quantity squared, but just...
Yeah, quantity, huh? Yeah, you're totally right. I knew it was looking weird to me. You could probably tell by my hesitation in my voice. Something's wrong there. Yeah, A1 plus n minus 1D. It's just how it's normally written. Yeah. So that's a formula you should put on your 3x5 card. That's the formula for cranking out any term along the way. In a little bit, I want to give you more of a feel for why that's true, but for now, let's just get used to using it. And when you're more comfortable, we'll talk about some reasons. But there it is, A sub 1 plus n minus 1D. That's the formula. So then I just plug in the stuff that they're giving me. Say, oh, okay, this is minus 7, D is 4. So then the A sub n formula they're looking for is minus 7 plus n minus 1 times 4. Is that good so far? And then I just distribute and gather like terms. Equals there. 4. So AN is minus, what would that be, minus 11, huh? That's like a slope again, isn't it? It's like an mx plus b. It's like a linear, it is a linear equation. That's like slope is 4, the y-intercept is negative 11. So there we go. Does that make sense? So we just, you'll just put, in fact, I'll give you this, I think, right at the top of the next exam. I'll give you this and a couple other formulas. We'll be using it a lot. So A sub n equals A1 plus n minus 1d. One part remaining. I wonder what else they want me to do on this one. Okay, so now we have this formula. We got it right here from the last part. Now they want me to use that formula to find A sub 75. That means the 75th term. In other words, can I jump all the way down to the 75th term? Yeah, just plug in 75, huh? Just take the formula minus 11 plus 4n and plug in 75 for the n. That makes sense? And so we get minus 11 plus, what's that one, 300? So 289. So the 75th term, like if you started listing out the terms, the 75th term down the road would be the number 289. So this is a formula which will crank out a bunch of terms, and the 75th term is 289. So once you have the formula, you can find any term. You can jump right to it. Good on that? All right, so to give that one a try, first find the formula, then find the 42nd term after you get the formula. So use that same general formula I gave you last time, A1 plus n minus 1d. So plug into that, get the general formula, and then use it to find the 42nd term. So A1 is minus 2. D is minus 8. Not good to there so far. Then distribute and clean that up. Minus 8n plus 8, like that. What is that? 6 minus 8n? Yeah. So there's our formula. That's the answer to part 1. That's the formula. Now find the 42nd term. So take that formula, an is 6 minus 8n, and the 42nd term will be plugging in a 42. 3, what's that? 320 and 16. 330. So minus 330, is that what it is?
Yep.
Minus 330 is the 42nd term down the road. Good like that? Questions on doing that? All right, try that one. They want the 17th term. And they're giving you the first term, that's A1, right? First term, and the difference, the D is 1/4. So same kind of thing. Find the formula. After you got it, plug in 17. So a sub n equals a sub 1 plus n minus 1d. A sub 1 is 8. and D is 1/4, right? So we're going to get, it might be easier just to make that a decimal. Make that 0.25, you know? Might be easier just to do that. Because fractions can be kind of a pain. Make it 0.25 and distribute that. 8 plus 0.25n minus 0.25, which is what, 7.75 plus 0.25n. Good to there. There's the a sub n formula. In decimals anywhere. Now, I'm going to come up here, and I'm going to try to find the 17th term. So the 17th term, a sub n again, is 7.75 plus 0.25n. So if I want to find the 17th term, it's 7.75 plus 0.25 times 17, which is something. What is that? 4.25, is that what that is? 0.25 times 17? 4 1/4, right? 4.25, right? And then add those up, and that'd be 11, 12. Clean 12. So there we go. 17th term is 12. That good? Makes sense on all that? So same thing, right? Find the formula, then plug in 17. And we're using the basic setup, which I still haven't explained where that came from. A1 plus n minus 1d. All right, you got that. All right, try that one. A1 is root 3, D is root 3. So use the same setup. A sub n is A1 plus n minus 1d. And they want the 32nd term. And they want an exact answer, so they don't want any decimals, they just want root kind of answer. A1 is root 3. D is root 3. Kind of getting sloppy here. Let me try that again. So A1 is root 3. D is root 3. So you can distribute that. Plus root 3n minus root 3. These cancel, huh? So AN is just root 3n. So then, coming over here, so AN, bring it over here, is just root 3n. Plug in 32. The 32nd term is going to be root 3 times 32. That's it. Can't really do anything more with that. That's just it. Is that okay? Questions on that? We all good? All right. So we've got 7, 14, 21, ... And they want me to find the 110th term. What do you think? Can you find the 100? This is the first term. N equals 1. N equals 2. Third term, n equals 3. How can you go all the way down and find the 110th term? Yeah, you want to find the a sub n formula. That'll help you. Yeah, use the a sub n formula, which is a1 plus n minus 1d, right? First find the general a sub n formula, then once you've got it, plug in 110. And you'll be able to jump down to the 110th term, right? That makes sense? So what's A1? 7, first term, 7, right? A1 is 7, good. So A1, the first term is 7. Okay, and then n minus 1. What's the D? What's the difference, the jump? Yeah, it's going up by 7. That's the D, the difference, the jump. So that's 7 also, huh? The first term is 7 and the jump is 7, right? Starting at 7 and it's going up by 7 every time. Those don't usually, they're not usually the same number like that. Okay? And then we distribute. And we get 7 plus 7n minus 7. These cancel. It's kind of like the last one. 7n. Okay, so come up here now. So you got a sub n is 7n. Find the 110th term. Plug in 110. 7 times 110. 770. Must be the 110th term. Does that make sense how we did that? So you first find the general formula. A sub n is a1 plus n minus 1d. Plug in the a1 first term. Plug in the difference from term to term, the jump, which is also 7. Clean it up, and then plug in 110. All right, let's try another one. All right, there you go. Find the 60th term. We have negative 3, negative 10, negative 17, dot, dot, dot. So first, find the a sub n is a1 plus n minus 1d. Find the general formula. And then after you've got the general formula, you'll come over here and find the 60th term. I gave you a second on this one. How y'all doing? Is that coming out okay? What's the A1? That'd be that negative 3. Okay, and what's the D? What's the difference from term to term? Good. It's going down by 7 every time, isn't it? The D, the difference, the jump, it starts at negative 3, goes down 7 to negative 10. Down 7 more to negative 17. Right? It's going down 7 every time. So the D is negative 7. All right, so now we distribute, get minus 7n plus 7. So what's that? 4 minus 7n. So we got the formula now. Right? So now with that formula, we can find any term we want, right? So we can easily find the 60th term. Just plug into the 60th term. A sub 60, 4 minus 7 times 60. 4 minus that, 420. Minus 4, 16. Thank you. Good there? This would be a good one to talk about where the formula comes from. So we good with that answer? We're done. We got the answer. We all good? Now, let's think back for a minute and just think if we could have done this ourselves. Well, I shouldn't erase that. That's exactly what we need. The jump from term to term is minus 7, right? Let's just go back and say, hey, could we have done this on our own without all this fancy formula stuff? Could we just kind of logicked it out? I think so. So we start at negative 3, and we go down by 7, etc. tell me what the 60th term will be without using fancy formulas. Could you do that? How would you do that? If I say, hey, I'm starting at -3, and I'm going down by 7, 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 tell me the 60th term in the list. What would you do?
59 times -7.
Do what?
59 times -7 minus 3.
Why 59?
Because it's one less than the term, it's one less than the first term.
Why is that?
Of all the total terms. I don't know, I'm just throwing it out there, I don't know if it's right, I'm just throwing something else.
Okay. Yeah, I want logic. So give me anything that makes sense to you.
Because we already have a first term, and we're trying to add up, we're trying to find the 60th term, we already know the first term.
Right.
So really, I think if we multiply the difference by 59, that should give us the 60th number.
The first term doesn't start at 0.
Right.
You have to,
Well, yeah,
you
I
have
think
to
Oh,
you
what
can,
if we did like -7
First
times
and you would
60
subtract the
by 4?
3 from it,
Subtract 3 from it.
or add 3 to it, you know, what you should. I mean, it's just a thought.
Can't we just start? No, it's a good thought. Can't we just start at that first term? How about we just start at -3?
Okay.
And then subtract 7, subtract 7, subtract 7. How many times? To get to the 60th term. Yeah. So Robert's right on that thought. Does everybody see his thought? Because at first it seems like 60. But Robert's actually right. And let me erase this. You guys have got it down, right? What was the answer? -416. Yeah. So at first you say, well, look, start at -3, right? Then subtract 7 60 times. Not quite. Only mistake is that's actually got to be 59. Then it's correct. Does everybody see that? Because think about a frog on lily pads. If you got a frog here, frog. I would draw a frog, but I can't draw. All right. So the frog is here, and it's going to jump. How many jumps to get to lily pad number 4? 3 jumps. There's always one less jump than the place you want to end up on, because you're already on the first lily pad, like Robert was saying, right? That makes sense? So if you want to get to the 60th term, that's 59 jumps, isn't it? Right? There's always one less. That's why the n-1 in the formula, you see. Right? So really it's A1, it's the first term. Then the D and n-1. That's where that comes from, you see. I'd stick the D at the back. I don't know why they do that. Whatever the reason, it's the same thing. Right? That's the formula because there's one less jump than there are lily pads, right? So that's what you do. You just go, yeah, -7, start at -3, and then subtract 7, the jump every time. Take 59 jumps of -7. And that'll be it. If you can do that by hand every time, that's fine. You get the answer. That's something I can't figure out. 424 -7, 413. Was the answer -416? Yeah, I just kind of fudged it. It worked. And no, that was right. Yeah, so you get to do that. If you want to just do it by hand, just think it, let's logic it every time. That's fine. That'll work too. That's where that formula comes from. All right. All right, try that one. 85th term. So you're starting at 3. You got to figure out the jump amount, though. You might want to change those to decimals. That might make it easier. Change those to decimals. You can't always do that, though, but you can do it on this one.
Since you have to. It's a simplified fraction.
Yeah, one fraction. We can always change it back over now. Either way. Either way. Yeah, maybe I'll just do it in front. Well, I've noticed it's just hard sometimes for people to do that. Change would be 13 fourths would be 3.75. Is that right? And 3.5. Wait, did I get it wrong? 3.25, is that what it is? 2.5, yeah, 3 1/4, huh? 3.5. I bet this is 3.75. Yeah. So it's going up by 1/4 or 0.25 every time, isn't it? Yeah. Yeah, so get the general formula, and then find the 85th term. So if you want to get to the 85th term, how many jumps? 84 jumps, huh? Getting the idea? You want to just logic it. But you can use the general formula. That'll work too. So A sub n is A1 plus n-1d. So the first term is 3. The difference from term to term is 0.25. Distribute that. Bring it up here. AN is 3 plus 0.25N minus 0.25. 3 minus 0.25 is 2.75 plus 0.25N. So there's our general formula. And then if we want to find the, the 85th term. 85th term. So plug A sub 85. Oops. I'm messing up here. 2.75 plus 0.25 times 85. 2.75 plus, for 20, is it 20? And then fourth that would be 20.25. And the other 22, is it 23?
21.25.
Oh, is that what it is? Thank you.
24 altogether, yes, 21.25.
So, yeah, thanks, Robert. You're right. So it would be 84. Yeah, exactly. So 24 then. Huh. Yes, thank you. So there we go. Good? Able to do those okay? Got a couple. This will be a bigger one. Okay. Yeah. Good. Okay, so we're on number 13. We're halfway through. This is good. We'll finish this tomorrow. So, all right, let's do this one. This is hard. They're going to give us information. 9th term is 17. 20th term is 50. Do all that and basically find everything in the world about the formula. Okay. Yeah, okay. Yeah, they want everything in the world. They want a recursive formula, they want a regular formula, they want the first term, blah, blah, blah. All right. Here's basically what we're going to do. 2 equations, 2 unknowns. That's how we're going to solve these. Let me just write out the general setup. AN is A1 plus N minus 1D. There's the general formula. Plug in the first 2 pieces of information. 9th term, A sub 9. It is A1, which I don't know, plus 9 minus 1D.
Instead of A sub 9, you put 17.
Yeah. I will. I'm just going to put it over there. But you're right. Everybody see, let me slow down a little bit there so I don't confuse you. When they say 9, here's what you got to pay attention to on these, and we'll do a lot more of this tomorrow, is when they put the 9th, that's an ordinal. I say that to help you recognize it, because this is where people they get confused. Now these are going to start getting messy, and over the years of teaching this, I've noticed students get confused on whether to put the numbers in for N, because sometimes, like this time, it goes in for N, and then sometimes it's like the A1 or the D, and they don't know where to put it when. Let me help. Anything that's an ordinal means like with a TH or an order. Ordinal means ordinal, like 5th, 6th, 7th. That implies there was like a race, and I came in 5th, or 3rd, or 2nd, or 1st. Those are all ordinal numbers, as opposed to just saying 3. 3 doesn't imply an order. It's just 3, right? Right? You could be in an automobile watching an auto race, right? It's car number 3. Or it's the car in 3rd place. That's a different thing. They have numbers on the top, and then there's their placement. Different things, right? So whenever you see the ordinal, whenever you see the TH, that's an ordinal number, that's always in. You always know that's an in, because that implies the order it's in. 1st, 2nd, 3rd, whatever. That always goes in the in slot. Ordinals do. So that's why I put the 9 in the in slot in both cases, right? And what did they tell me the 9th term is? This is the 9th term, and it is 17, they told me. Make sense so far? Now let's do the next one. 20th term is 50, so that's A sub 20. 20 is the ordinal, it's the N, right? 20th is A1 plus 20, again it's N, minus 1D, and that equals what? 50. The 20th term is 50, equals 50. So you see what I got here with these two? 2 equations with 2 letters. What are the 2 letters? A1 and D. A1 and D are my 2 letters, which I don't know, I want to find, and I've got 2 equations with A1 and D. I can solve 2 equations and 2 unknowns. So let's do it. So come on down here. I'm going to clean it up first. 9 minus 1 is 8D, and 20 minus 1 is 19D. Everybody good to there so far? 2 equations, 2 letters. I can solve it. Now, I'm going to do the addition method. Super easy way to do addition method. Just run a negative sign through the top equation. and negative A1 and positive A1 will drop out, and you'll have D in a matter of seconds. Does that make sense? Always solve these kind this way. So I'm going to run a negative sign through the top equation, just multiplied through by -1, effectively, right? It's okay to do, did the same thing to both sides, didn't change it. They were equal before, they're still equal, I multiplied both sides by -1. Now you add them up, A1's cancel, 19D minus 8D, that's 11D. 50 minus 17 now is 33. And how do you solve for D? Divide by the 11, D is 3. Got my hands on D? Bring it up here. So got D, bring it up, D is 3. Now that I got 3, I can get A1, right? Plug it in. Plug in D equals 3. Where? Anywhere you want. I'll just grab this formula before I did the negative. A1 plus 8D is 17. Plug in the 3. A1 plus 8 times 3 is 17. A1 plus 24 is 17. A1 is just subtract 24 from both sides. And I don't know what you get. Minus 7. A1 is minus 7. We got it. We got the formula. A1 is minus 7. So the formula A sub n is A1 plus n minus 1D. We've got it. A1 is minus 7. N minus 1D is 3. There's the formula. We're out of time. We can clean it up and answer their other questions easily. That's the lion's share of the work right there. We'll do another one of these next time. All right, this is not due till after spring break, really.